Hello everyone, myself S.JYOTHI Lakshmi, Department of Physics, A.D.M. College, Autonomous Nagapattinam. Now we are going to discuss about an energy physics. Introduction to energy sources. What is energy? The physics energy is defined as a capacity to do work. It extends the various forms such as kinetic energy, potential energy, thermal energy, chemical energy, electrical energy, nuclear energy, and radiant energy. What is kinetic energy? The kinetic energy is the energy due to motion. Potential energy, stored energy due to position. Thermal energy associated with temperature. Chemical energy stored in the molecular bonds, and electrical energy is due to movement of electrons. The nuclear energy is stored in the nucleus of an atom. And the last one is the radiant energy. Radiant energy is carried by the light, that is electromagnetic radiation. Introduction. Energy powers expert as modern life. Global prosperity, but is closely tied to energy availability. Next, what is energy matter? The energy matter is the fundamental to industrialization, transportation, communication, and agriculture. Energy used per capita is a key indicator in economic development. Physics connect energy consumption, work done, and entropy is produced. And the energy versus GDP. GDP means gross domestic product. The gross domestic product is the total numeric of value of all goods and services produced within a country in all specific time periods. It measures the nation's economic performance and overall economic health. Positive correlation between the energy used and the GDP. In developed nation, they are using the high GDP. In some countries shows the without proportional energy increases, that is decoupling. UK, Germany, Denmark, and Japan. Because they are using the shift from manufacturing to services, investment in renewable energy and the nuclear. Improved energy efficiency and building standards. Global disparity in energy use. Top 10% of the world consumer over 50% of the total energy. That is Sub-Saharan Africa. 600 million people with less energy used than New York. Disparities and inequality, often minor energy availability. Energy intensity. Energy used in a unit of GDP. Indicator of efficiency is the low intensity is equal to more GDP per energy unit. Developed economic tends to reduce intensity over time. The physics of growth. Thermodynamics. Energy input is work for waste heat entropy. Industrialization growth increases energy towards goods. And Taylor's law. Society collapse with the energy, returns on investment drops low. When the energy returns on investments, that is the ratio of energy gained to energy spent, becomes too low. The system becomes unsustainable. Renewable energy and the sustainable prosperity. Fossil fuel power prosperity for 200 years. Physics limit finite fossil fuel. Climate impact require a shift. Renewable, solar and wind, often fought to sustained energy without ecological collapse. And beyond quantity and quality of energy used. Not just how much, but how widely. Electrification, small gains, and decentralized system increases reliance. Energy equality and access are central to global bridges. Next, energy returns on investment. Energy returns on investment is equal to energy gained by energy invested. That is, the fossil fuel declaring the energy returns on investment is less than 15:1. Renewable improving, that is solar and wind. Solar 5 to 10:1 and wind approximately 20:1. Present energy landscape. Oil contains approximately 31%, coal approximately 27%, natural gas approximately 24%, and renewable energy approximately 12%, positive growing. Nuclear approximately 4%, high energy density and low carbon. Future energy technology. Solar power, PV means photovoltaic cells, scalable. Wind, kinetic to electrical. Hydrogen, fuel cell storage. Fusion and battery storage. This is the physics of materials. Sustainable energy futures. Net zero by 2025 Paris Agreement, that is electrifying the transport and heating. Research, nano superconductor and thermoelectric. Sustainable energy future. Net zero by 2050 is the Paris Agreement. That is, net zero means balancing the amount of energy, greenhouse gases emitted with the amount of removed from the atmosphere. Electrifying the transport and the heating. Research, nano, superconductor, thermoelectric. Conclusion. A call to action, not just the politics or engineering, it's just a physics challenge. Energy physics students are the future innovators, modern design and optimizing the future energy system. Introduction to energy sources. Energy is an essential for development and the quantity of life. Energy source can be classified into renewable and non-renewable. That is, understanding the availability helps in sustainable planning and usage. Classification of energy sources. Non-renewable energy and renewable energy. Non-renewable energy means example coal, oil, natural gas and nuclear. Renewable energy means solar, wind, hydro, biomass and geothermal. Non-renewable sources. Fossil fuels. Formed over millions of years from organic matter, that is finite and causes pollution. Nuclear energy is derived from uranium fission and high energy output but hazardous waste. Renewable sources, solar energy, wind energy, hydro energy, biomass and geothermal. Solar energy means abundant clean, need to meet sunlight. Wind energy, efficient in windy regions. Hydro energy, need rivers or dams. Biomass is an organic material like wood and waste. Geothermal, heat from Earth's interior. Global availability of energy sources. Fossil fuel concentrated in the Middle East, USA and Russia. Solar is best in tropical and arid zones. Wind, coastal and highland areas. Hydro, countries with the rivers and the elevation. Is biomass available globally, especially in the rural areas. Global availability, energy source and the 3 point and the notes. Gold, China, India, Russia is a region and its notice high reserves but declining use. Oil, Middle East, Russia is major export commonly. Natural gas, Russia, USA, cleaner than coal, used in transition. Solar, India, Australia, Africa is a high potential in equatorial zone. Wind, Europe, US, and China is a large offshore wind farms emerging. Hydro, Norway, Brazil, and Canada. Mature technology, ecological concern. Geothermal, island, Indonesia, localized potential. Conclusion. Diverse energy system. The world relies on the both renewable, that is solar, wind, hydro, and non-renewable coal, oil, gas, and nuclear sources. Each has unique advantage and limitation regarding the sustainability, cost, and environmental impact. Availability varies geographically. The resource the resources distribution is uneven across the global. The solar is abundant in equatorial region, fossil fuels are unconcentrated in the specific countries, and hydro depends on topography and water force. A transition towards sustainability to meet growing demand and combat climate change. Nations are shifting towards the clean, renewable energy backed by the technology innovations like smart grids and energy storage and hydrogen. Challenge and the opportunity. Non-renewable and the pollution renewable requires the infrastructure investment and the storage solution. Next one is the conventional energy sources. Conversion has two types, conventional energy sources and non-conventional energy sources. And non-conventional energy sources. Energy. Energy is an important input of development. It aims to natural resources. Energy resources are also renewable as well as non-renewable. Renewable energy resources. Energy resources that are easily replace the after being consumed. Non-renewable energy resources. Energy sources that are not replaced or after being used. It may take several years of the to replace. Source of energy. There are two types of source of energy. One is conventional energy, a conventional source. Next one is a non-conventional source. Conversion has two types, commercial and non-commercial. Commercial is coal, oil, natural gas and thermal power. Non-commercial is firewood, hydropower, nuclear power. And the non-conventional sources is solar energy, wind energy, tidal energy, geothermal energy, biomass energy, based energy. Is based on energy. Conventional energy sources. Energy that has been used from ancient times is known as conventional energy. The conventional the conventional resources are one of the commonly used, like pencil or pen. These are available in a limited amount and developed over a longer period. As a result of unlimited use, they are likely to exhaust one day. These are the non-renewable or exhaustible energy sources. It's a pie chart for the conventional energy sources. Coal has 29%, hydro energy has 29%, nuclear energy has 28%, natural gas has 7%, and crude oil is 7%. Conventional energy source has two types of sources, like conventional energy sources, non-conventional energy sources. Conventional energy sources. The sources of the energy that are usually available in costly to use refers to as commercial energy sources. Non-commercial energy sources. The source of the energy that are usually available in free to cost that used to often to as non-commercial energy sources. Commercial energy sources. First one is the coal. Coal releases large amount of energy. It is bounded because of the density of hydrocarbon in the material. Coalification. Coal is formed by the jet plants being put under significant pressure and temperature for millions of years. There are four grades of coal: lignite, bituminous, and anthracite. Lightning. It is a brownish black coal of low quality with inherent moisture and volatile nature. Energy content is lower, 4000 bulbs. Bituminous. It is a black lignite, is dull black and generally contains 8300 bulbs. Bituminous. Most common coal is dense and black. Its moisture content usually is less than 20%. Energy contained above 10,500 bulbs. The last one is anthracite. It is a hard black luxurious coal, often referred to as hard coal. Energy contained above 14,000 bulbs. Oil and natural gas. It is a sedimentary rock containing plants, animals, and remaining above 10 to 20 crores years old, are source of mineral oil. Mineral oil is very unevenly distributed over space like any other material. There are 6 regions in the world which are rich in mineral oil, like USA, Mexico, Farmer, and USSR, and the West Asian region are the major oil reproducing countries. Natural gas is really a mixture of gases that formed from the fossil remains of ancient plants and animals buried deep in the earth. In India, gas is a natural gift. The main ingredient in the natural gas is methane. Natural gas has been used both as energy sources and also an industrial raw material in petrochemical industry. The gas is also used for fertilizer and plants. Through pipelines, the gas has Bombay and the Gujarat gas field is now taken to MP, Rajasthan and UP. And if the pipeline is the Hadza Behu Chhattisgarh has the pipeline is the 1730 kilometer long carrier, 18 million cube meters of the gas every day. It feeds 6 fertilizer and 3 power plants. There are already 12 refiners in India. LPG means liquefied petroleum gas, also called as cooking gas, is now very common domestic fuel. Thermal power. A thermal power station is a power station in which a heat energy is converted to electrical energy. The thermal power plants use coal, petroleum, and natural gas to produce thermal electricity. This serves as a mineral origin, also called fossil fuel. They are extractable and polluting. This is in the great demand in industry, agriculture, transport, and the domestic sector. Non-commercial energy sources, firewood. One most combined supply of the firewood and other biomass energy sources. Besides, we need technology for the total utilization of the biomass and all conversion is a conversion to solid, liquid, and gaseous. Solid is densification, liquid is liquefaction, and gaseous is gasification. Hydropower. Water energy is the most conversion renewable energy sources and obtained from water flow and water falling from a height. Hydropower is a clean, non-polluting source of energy. It can be transmitted to the long distance to the wires and cables. In South America, about 75% of the total electricity consumption comes from water, and Japan, USA, and the former USSR are leading countries for protection of hydropower. In India, the generation of the hydroelectric power was in the first 5 years. We have referred to the dams of earlier in chapter on natural resources and their conservation under land use resources. Nuclear power. A small quantity of the radioactive material can produce abnormal amount of energy. For instance, 1 ton of uranium-235 would provide as much energy by 3 million tons of coal or 12 billion barrels of oil. Atomic power is also used as fuel for marine vessels. Heat generation for the chemical and the food processing plants come from passive gas. For atomic energy, we need nuclear reactor. There are the different type of nuclear. What LWR? LWR means light water reactor. Here we use the ordinary water for cooling and moderation. There are two types, basic type. One is the boiling water reactor. Next one is the pressurized water reactor. Heavy water reactor is used in heavy water. Liquid metal caustic reactor. We use liquid sodium as a coolant. Non-commercial energy sources. Energy that has been used from natural resources which are made by the artificial is known as non-conventional energy sources. A non-conventional energy sources are one that work but not commonly used, like ionic laser. These are available in unlimited amount in energy since they are renewable over a short period of time. It can produce themselves in the nature. These are also known as the renewable and inhabitable energy resources. Solar energy. Energy obtained from the sun is a form of heat and light. Energy derived in the form of solar radiation. Solar radiation received by the Earth space is approximately 1.4 kilojoules per second. Is known as solar constant. The heat energy is used in the solar heating device like solar cooker, solar water heater, solar furnace, etc. The light energy is used in solar cells. Using the photosynthesis and biological process for the energy trapping, in the process of photosynthesis, green plants absorb solar energy and convert chemical energy stored in the form of carbohydrates. Wind energy. Air flows can use in the run wind turbines. Wind energy is used in the windmills, which is converted the kinetic energy of the wind into mechanical or electrical energy. A signal windmills provides only a small amount of electricity. A large amount of windmills in a large area coupled together to produce more electricity in the windmill farm. Minimum wind speed requires 15 km per hour. At the present, wind power potential of the energy is 1020 megawatt. The largest wind farm is near Kanyakumari in India. It generates 380 megawatt electricity. Tidal energy. The energy associated with the tide of ocean can be converted into electrical energy. The first tidal power plant was in France in the year 1996. India got taken up the ocean thermal energy conversion, and the process is capable of generating the 50 50,000 megawatt electricity to meet the power requirements of remote ocean, oceanic island and the coastal towns. Geothermal energy. The geothermal energy may be defined as the heat energy obtainable from the hot rock and present inside the earth's crust. At the core temperature may reach over 9,000 degrees Fahrenheit. This heat comes from the friction of radioactive material naturally present in the rock. The deeper region of the earth's crust is very hot. This heat melts the rocks and forms magma. Magma moves up and collects below at some places called hotspot. The underground water the underground water in the contact with the hotspot gets heated into steam at high pressure. By drilling holes into the hotspot, the steam coming out can be used to rotate the turbines of generator to produce electricity. Biomass. The organic matter originated from the living organisms like wood, cattle, and sewage, agriculture waste, etc. are called biomass. This substance can be burned to produce heat energy, which can be used in the generation of electricity. Thus, the energy provided from the biomass is known as biomass energy. Merits and demerits of the conventional energy. Merits and demerits. High energy output causes air, water, and soil pollution. Well established technology. It emits greenhouse gases, climate change. Reliable and constant supply, finite resources, and not reliable. Infrastructure already in place, mining and extraction damage the ecosystem. Cheap in short time, health risk to workers.